In this session, we are going to do the analysis and design of a RCC continuous beam using Staad Pro software, and I am going to show you the problem. And this is the continuous beam having 3 spans with the fixed ends, and the point loads and UDL load are given here along with the length of spans. And we are going to use the Staad Pro V8i software. Now I am going to shift to this software, and this is the first screen. As we know, we click on the new project, select the plane frame and give the file name here as continuous beam. You can give as some extension, and I have taken the length units as meter and force units as kilonewton, and click on next, click on add beam and click finish. Sorry. And you will see the grid pattern now, but you click on setup in the modeling mode, and so as to give the job name, I'm going to give a job name like this, and client, and give the name, and give the name of the engineer, and next you can close this window, and you can click on this geometry. You can close this snap node beam window so as to give the nodes. Here we are having the 3 spans, so for the 3 spans means you will be having 4 nodes, and the first node is the left hand support. The coordinates of this node will be 0, 0, 0, and the second node will be, the span is 3 meters, so it is 3, and the third will be, so x coordinates of the third node, it will be 6, and the coordinates of the fourth node will be, so it is 6 plus 9.5, so like this. And for the beam 1, the node A is represented as node 1, and node B will be represented as node 2, and for beam 2, the node 1 will be, node A will be represented as 2, and node B will be 3, and for the third beam, node A will be 3 and node B will be 4. So this is the way how we have to give the node numbers. And now we can see the beam, and we can click a view from plus that. So this is the front view. To see the nodes you have to press shift N, and now you can see all the nodes here. After that you click on general tab and click on property and click on define, and select the rectangle and give the depth as 0.5 and the width as 0.23, and see that the material is concrete, and click on add and click on close. Now select the support tab, and you have to give the supports as shown in the figure. There is a fixed end at node 1 and node 4, and pinned support at nodes 2 and 3. So we have to create the 2 types of supports. One is the fixed support, so this is the one. Click on add, so the support is added. S2 is fixed support. Now click on create and click on this pinned support and click on add. So the 2 supports are created. Now select the support S2, which is a fixed support, and use assign to view option to assign the supports to the beam. So select this one and select assign to view, click on assign. Yes, oh sorry, so you have to select the assign, use cursor to assign. So what I'll do, I'll just go to undo. Okay, I have to do undo support. So now I'll click on this use cursor to assign, use cursor to assign, and click on node 4, and click on assign. So the two ends are assigned fixed support, and select the support 3, which is a pin support. Use cursor to assign. You have to select this option, otherwise assign to view means it will be assigned to all the nodes. So just save it. So use cursor to assign and click on assign, and click on node 2 and click on node 3. So all the supports are assigned now. Close it. Now after the supports, assigning supports, click on loads. So here it's a little bit tricky part. I am always saying this. You have to practice many times to create the loads and to assign the loads and all those things. So here you have to see the diagram perfectly. The point load in the first span, and UDL load in the second span, and point load in the third span. So you have to create the loads similar to this one. So for that one, the procedure is first select the load cases details and click on add, and select the loading type here as dead load and load case 1. Just click on add, and also here you have to add this auto load combination. So select the Indian code, select this Indian code and generate loads, and bring it all here and apply a factor of safety of 1.5 times. Select this one and click on this and click on add and close it, and now click on this load case 1 and click on add, and here you have to add the point loads and UDL loads. So click on member load. So member load, in this you are having uniform force, that is UDL load, so which is here it is minus 15. Okay, so it is in second span, so D2 will be 3 meters. Okay, so you have to click on this add. So now select the concentrated force. So here the concentrated force is minus 10 in the first span, having a distance of 1.5 meter from the left support of the first span. So of course this direction is GY, global Y, and I told minus sign is for the force is acting downwards. So click on add, and one more point load is there, that is minus 7.5, and it is acting at a distance of 1.75 meters from the left support of third span. So click on add. Now close it. So and of course you have to add the self weight you have to add. Same procedure to add this load. Select the self weight and it is minus 1. Click on add and close. So here all the loads what you have selected are added here. You have to apply the loads as per the created sequence. So here the uniformly distributed load you can see here as 15 kilonewton per meter. So this is in the second span. So you have to select the option of assignment as use cursor to assign and click on assign and click on the second span. So it will be applied on the second span. Don't click on first or third spans. So now the question mark disappeared here. Now select the concentrated force 10 kilonewton. So it is in the first span, so click it in the first span. You can see the load. And the third one, see, this is 7.5 kilonewton and you have to apply the third span. So this is the one, and you click on self-weight. Self-weight has to be applied to all the 3 spans. So you can select this option, assign to view, and click on assign. Say yes. So this indicates, the red line indicates the self-weight is assigned to all the 3 spans. Okay. So this is the load factor 1.5 times, it will be there. So to see the values, of course you have to press shift V. Okay, you have to save it and press shift V to see the loads here, and it is uniformly distributed load of 22.5 because the load factor is 1.5 times. So that's why it is showing 22.5. So we have increased the load by 1.5 times. You can also apply the loads without considering this load factor also. Then it will show you as it is 15 kilonewton per meter. Okay, so once you have applied these loads, and the next one is material. Of course we have already assigned the material. So once again you select this one and assign to view, click on assign, click yes. So this is all the concrete material. So once these all tabs are over, that is, we have given the properties, we have given the supports, we have given the loads, and we have given the material and assigned to the continuous beam. Now the next part is analysis part. So you click on analysis and print of the modeling tab and click on all and click on add and close it. So you can see here all the steps what you have done or listed in sequentially. The next part is go to the analysis part and select the analyze menu, click on run analysis, and of course it will now save. There is a error in the output file. Okay, so section properties not entered for member 1, section properties member 2. So we have not, I think we have not assigned the properties. So we have created, but we have not assigned. So you can say assign to view and assign, say yes. So now it is assigned. So if you have not done anything, so it will show you some problem is there in the analysis part. So the sections are assigned now. So now you can carry out the analysis, run analysis, save it. So now you can see there are 0 errors, 0 warnings, and everything is okay. So if you have forgotten anything, don't get panic. You just see what's the problem with the sequence of steps, then understand this and correct the components. Any warnings are to be corrected, then you can again do the analysis. So run analysis will show you how you have carried out the process of this problem using this strategy. The sequential steps you have to follow, then it will be fine. So once you have performed the analysis, just you can go to post processing mode, click on done, select that one and click on done, and you select this OK, and you can see the load case 1 and generated factor of safety for loads is both selected. Sorry. Now you can see the reactions. Click on the reactions to see the reactions here. You can see the moments. So the end moments are given here, and you can see the reactions. So once it is done, you can also see the bending moment diagram. Click on this MZ. You can see the bending moment diagram here. So and you can click on the Y to see the shear force diagram. Okay, so that means you can also see the displacements here, though due to the loads and Y given here the displacements. So once it is over, post processing, the next step is you have to carry out the design part. So click on the modeling mode to carry out the design. Select the design tab. So here you have to specify the parameters. You have to select the parameters which you want. So before that you have to select the concrete tab, and here in the current code you have to select the IS 456 Indian Standard code for the design of concrete, and select the parameters. Click on that one, and now you select whatever the parameters you want to select. Generally we select for the FC, compressive strength of concrete, and F5 for main and secondary, and the maximum diameter of bars for main reinforcement and secondary, and the minimum diameter of the bars, and width of the cross section. So once you select, holding the control key, you select all the parameters and click on this single arrow, and all these parameters are selected, and click OK. So the selected parameters are over. Now you have to define. Click on the define parameters to give the values here. So for the FC, compressive strength of concrete, you have to give M25. Once you type, you click on add, and for FY it is 415. So it is added. So you have Y secondary, you can add 415, P450, add, and the maximum diameter of the main reinforcement I have taken as 20. Okay, you can add it. And maximum secondary is 12, add it, and minimum diameter of the main reinforcement I have taken this also 20, add, and minimum of secondary is 8, add it, and width of this section I have given earlier as 0.23. So if you want to change here, you can change this value and click on add and close it. So whatever the parameters you have added will be listed in the window here, and you click on the FC. So this question mark indicates we have not assigned these parameters to the beam. So what you have to do is you have to click on the FC and assign to the beam. So you have to assign to all the 3 spans. So you select assign to view and click on assign, and click on S. So FC is assigned, so you can see the green tick mark. Similarly, you carry out with all the parameters in the same way, so that all these parameters are assigned to the beam. The maximum diameter and the minimum diameters and all are assigned. So before you are proceeding for the design of beam or column or whatever. So you have to select the parameters and define the parameters, and you have to assign to the view, so that all these parameters are assigned to the beam. So you can see green tick mark, that means we have assigned. The next one is you have to click on commands and select the beam, design beam. So it gives the design of a beam. Click on add, and you click on take off, click on add. So this will take off, will calculate the quantity of concrete and steel. So click on close, and once again check for any question marks. So design beam, just we have added. So this you have to assign to the beam. So select this one and use this assign to view, and click on assign and say yes. So all the parameters are added. So now it's time to go for the analysis. So run analysis, and this will do the analysis part and the design part. So let us see. Save it. Now you see all the process is over, and you can see the 0 errors and 0 warnings. And click on this output file and click done. Now you see the complete design analysis and design part, starting from the whatever the job you have given, continuous beam, and client name, engineer name, everything listed here. And you can see the problem statement, statistics, number of joints, number of members, and number of supports, everything listed here. You can see the loading, and also you can see the movements here. And this is the concrete design. So the code is Indian code, and you can see all the values of FC, FI, and diameter of the bars. You can see the the length is 3 meters. This is for the first beam number 1. So it is listed like this. And next you will see the beam number 2, the number of bars. For beam number 1, you can see the top is 2 bars and bottom is 2 bars. And you can see the diameter of the shear reinforcement 8 mm at 300 mm center to center. This is for beam 2. It's also same, and for beam 3. So all the reinforcement is given here separately, beam by beam. And you can see here the total volume of concrete is 1.1, and this is the weight of steel, 8 mm bars and 20 mm bars weight, and it is 1074 kgs. Okay, so this is the end of the Staad Pro analysis and design. So if you want, you can close it, but it is better to save it. You can take a printout and save in the PDF format. And this is having 7 pages. So click on OK. So all the 7 pages will be saved. So you can give the file name here. I'll give the file name as continuous beam design. So click on save. So this will be saved, and now you can close it. So to see the reinforcement details, you can double click on the beam. You can see the geometry and beam number 2 loading. Wherever you click it, it will show you the details of beam number 2. Suppose if you click on beam number 3, so it will show the concrete design for beam number 3. So this also you can save it. Take a printout of this one and in the PDF format, so it will be saved. You can give the concrete design reinforcement details. Beam 3. name, and this will be stored, and close it. So like this you will carry out the the analysis and design of a continuous beam. So in the end of the the lab manual, I have given the exercises. So this is, I have listed all the procedure. You can follow it and you can verify it. And these are the beams I have given at the end of the manual. At the end of the topic. You can use the Staad Pro to analyze this beam, or you can take any beam from your textbooks and carry out the analysis and check the values whether the manual calculations are correct with the Staad Pro or not. Okay, so this is the way how you have to carry out the analysis and design of a continuous beam. Thank you.